Hello guys, this is Dr. Haytham Aiso, physics tutor speaking to you. Today I'm gonna start to solve some questions from past papers, physics IGCSE 0625. But please first, don't forget to comment, share and subscribe my channel Lab Time Academy. And also you can click on the bell icon to get notification. If you have any idea, any question, you can write in the comment. Thanks a lot. Hello guys, today I'm gonna start to solve some questions about electricity physics IGCSE from past papers. Let's start with the first question. This question from paper 4 variant 3 May June 2021. This question was question number 7. Define the electromotive force. First of all, we know the meaning of the electromotive force, which is EMF. Actually, electromotive force is the electric energy gained by each column of a charge as it is pushed by the battery in the electric circuit. B. Figure 7.1 shows a circuit. As you see, here we have a battery, 12 volt, EMF equal 12 volt, and here we have metal wire, which is PQ, and here we have two lamps. These two lamps are connected in parallel, as you see. The two lamps shown are identical. Each lamp has a potential difference of 3 volt. So this potential difference of this lamp, 3 volt, the potential difference across this lamp, 3 volt, all of them are connected in parallel, so the electric or the potential difference will be the same because they are connected in parallel. Okay. And the current of 2.0 ampere in it. So here we have the electric current that passed through the first lamp was 2 ampere, and the electric current that passed through the second lamp also 2 ampere. PQ is the length of the uniform metal wire. The resistance of PQ is R. He asked me to calculate the value of the R. How can I calculate the value of the resistance of PQ? Okay. Actually here you can see that this battery has an EMF which is 12 volt. And here we have two lamps. These two lamps, as I said, connected in parallel connection. So here he said the potential difference of 3.0 volt across it. So here if I have voltmeter, when we connect the voltmeter with these two lamps, the reading will be 3.0 volt. So this means that here we have 12 volt, which is the total voltage, total EMF of this electric circuit, and here we have 3 volt across these two lamps. So I can calculate the potential difference across PQ. How can 12 minus 3? Why? Because these two components, which are the two lamps and the metal wire, which is PQ, connected in series. And you know the connection in series, if I want to calculate the total voltage, I can, or I have to add the two components or the potential difference of the two components. So here first we can get the potential difference of PQ. 12 minus 3 volt equal what? Equal 9 volt. So here the potential difference across PQ is 9 volt. The second thing he said, the electric current that passed through the first lamp is 2.0 ampere, and across the second lamp 2.0 ampere. So this means that the total current was 4.0 ampere. Why? Because they are connected in parallel connection. So I total equal I1 plus I2, so the total current is 4.0 ampere. But take care, actually here, as we said, the two components are connected in series, and you know that the electric current, if we have more than one component in series, will be the same. So here the electric current that passed through the two lamps was 4.0 ampere, and also the electric current that will pass through PQ equal also 4.0 ampere. So we have here the electric current, and here we have the PD, which is the potential difference. So by using Ohm's law, I can calculate the resistance of PQ. So here, as we said, the electric current across the two lamps is 2 plus 2 equal 4 ampere, as we said, because they are connected in parallel. So the current across PQ equal 4 ampere the same. Why? Because these two lamps and the PQ connected in series, and the electric current across series connections will be the same. Also PQ or PD across PQ equal 12 minus 3 equal 9 volt. Why? Because they are connected in series. So we can get R equal V over I from Ohm's law. So 9 over 4 equal 2.25 ohm, and this is the final answer. Another piece of wire is made of the same metal as PQ. The length of the new piece of wire is twice the length of PQ. The diameter of the new piece of wire is twice the diameter of PQ. Calculate the resistance of the new piece of wire. He asked me to calculate the new resistance. Actually, in this question, we have two main points. The first point, he said the new piece of wire is twice the length of the PQ. And the second point, diameter also will be twice. The diameter of the new piece of wire is twice the old diameter. The first point, the relation between the length of the wire and resistance. Actually, you know that we have directly proportional between the length of the wire and its resistance. By increasing the length of the wire, its resistance will increase. So this means that he said the new piece of wire is twice the length. So also the resistance will be twice. The resistance will be doubled because we have directly proportional between the length of the wire and its resistance. So R will be equal to 2.25, which is the old resistance in the last question, will be doubled or twice, times 2 equal 4.5 ohm. The second point, the diameter of the new piece of wire is twice the diameter of PQ. Actually, we have inversely proportional between cross-sectional area of the wire and its resistance. By decreasing the cross-sectional area of the wire, its resistance will increase. And here he said the diameter of the new piece of wire is twice the diameter of PQ. So this means that its resistance or the resistance will be decreased by the factor 4. So here R will be equal 4.5 divided by 4 equal 1.1 ohm. Actually, we can prove the second point. How can? We know that R1 over R2 equal R2 square over R1 square. And you know the R is the radius. And the radius equal diameter over 2. Okay? From where we get the R2? Because the area of the wire equal by R square. So the by will be cancelled from up and down. Will be cancelled. Okay. So here he said the diameter of the new piece of wire is twice. So here we have doubled here. So R1 over R2 will be equal, he said twice. So 2D over 2 will be squared. So it will be D squared over 4. So D square will be cancelled with D square. So R1 over R2 equal 4. So this means that R2 will be equal R1 over 4. So the new resistance equal the old resistance divided by 4. So here 4.5 divided by 4. So you can obtain 1.1 ohm. This question from paper 4, variant 2 May June 2021. This question was question number 8. Two identical radioactive sources emit alpha particles and gamma rays into the vacuum or two vacuum tubes. Figure 8.1 shows two electrically charged plates on either side of one of the vacuum tubes. Write the symbol alpha once in table 8.1 to indicate any deflection of the alpha particles, and write the symbol gamma once in table 8.1 to indicate any deflection of the gamma rays. Actually, here in this question we want to mention the direction of each alpha particles and gamma rays. All of you know that gamma rays has no charge, does not carry any charge, just rays, so it will move in a straight line without any deflection. So this means that no deflection in case of gamma rays. What about the alpha particles? You know that alpha particles is the nucleus of helium that carry positive charge, and here we have negative plates. So this means that the positive will be attracted to the negative, so it will move towards the bottom of the page. Why? Because it carry positive charge, and here we have negative plates. It will be attracted to each other, so it will move towards the bottom of the page. Double I. Figure 8.2 shows the poles of very strong magnet on either side of the other vacuum. Actually, in this question, the electric field replaced by two poles of strong magnet. We have N pole and we have S pole. So we want to mention the direction of each alpha particles and gamma rays when it moves between the poles of strong magnet. The same thing will happen to the gamma rays. No deflection of the gamma rays, as we said before. So the gamma rays, no deflection. What about the alpha particles? We want to mention the direction of the alpha particles when it moves through the poles or between two poles of a strong magnet. Actually, in this case, as you know, we have to use Fleming's left hand rule. As you know, we said we have first finger will point to the direction of the magnetic field here from N to S, and the second finger, which is the direction of the current, but your thumb will point to the direction of the force. So here, the direction of the magnetic field, as we said, just from N to S pole, and the direction of the current, it is the direction of the motion of the alpha particles, means to the right, direction to the right. So your thumb will point to the direction of the force, so it will be into the page. Next question on the same paper. Figure 9.1 shows a circuit. On figure 9.1, draw two clearly labeled arrows to show the direction of the electron flow and the direction of the conventional current in a circuit. Actually, we have a difference between the direction of the electron flow and the direction of the conventional current. The direction of the electron flow starts to move from negative pole of the battery to the positive pole of the battery. So the direction of the electrons from negative to the positive, as you see. What about the direction of the conventional current? Opposite to the direction of the electron flow. Start to move from the positive pole of the battery to the negative pole. Next, B. The current in the motor is 13 ampere. The charge on an electron is 1.6 times 10 to the power of negative 19 coulomb. Calculate the number of the electrons that pass through the motor every second. Actually, we have to write the given first. Here we have the electric current, which is 13 ampere, as you see. And the charge of the electrons, 1.6 times 10 to the power of negative 19 coulomb. And he asked me to calculate the number of electrons. What about the law of the number of electrons? N equal Q over E. Here we have E, but we didn't have Q. So we have to get Q first. Q equal I times T. As you know, electric current times the current equal electric current, which is 13, as you see. He said every second. So the T equal 1 second equal 13 coulomb. So N equal Q, which is 13 coulomb, divided by electron or charge of the electron, which is 1.6 times 10 to the power of negative 19 equal 8.1 times 10 to the power of 19. That's it. Question 10a. Figure 10.1 shows the potential difference current graph for a circuit component K. Calculate the resistance of component K when the current in it is 4.0 milliampere. First of all, we have to convert milliampere to ampere. You know that I equal 4 milliampere, and if you want to change from milliampere to ampere, so we have to multiply by 10 to the power of negative 3. It's going to be 0.004 ampere. Second, we want to calculate the resistance from Ohm's law. R equal V over I, resistance equal to the potential difference over electric current. So we can get the potential difference from the graph. Here he said when the electric current equal 4.0 milliampere. So here 4.0 milliampere, from the graph we can get the V. So here the V will be 10 or 9.2. Just we can draw just line from 4 milliampere till it reach the curve, and from the curve till it reach the y-axis, which represented by potential difference. So it's gonna be 9.2 volt. After that, just we can put the numbers R equal V over I. So it's gonna be 9.2 over 0.004 equal to 1300 ohm. That's it. B. Figure 10.2 shows a circuit containing component K. As you see, this is a thermistor. At low temperature, the component K has much greater resistance than resistor R. And at high temperature, the component K has much smaller resistance than resistor R. State and explain the effect on the lamp when the temperature changes from very low to very high. Refer to the voltage at point X in your explanation. We have to mention the voltage at point X. So what will happen here? Actually, we know that the thermistor at high temperature, what will happen by increasing the temperature of the thermistor? Its resistance will be reduced, or its resistance will decrease. So this means that we have electric current will move through the lamp, and we have larger current will move through the lamp. Why? Because as I said, at high temperature, by increasing the temperature here, the resistance of the thermistor will decrease. Resistance of thermistor will decrease. And the voltage or the potential difference across R will be more, will increase. So larger electric current will pass through the lamp. More electric current will pass through the lamp. So the lamp will glow. And the explanation: at high temperature, the resistance across thermistor will reduce, and voltage across R, which is the resistance or resistor, means the potential difference across the point X, as he said, point X will increase. So larger current in lamp will be passed through the lamp. C. State the name of the component K, as we said, thermistor. Thanks a lot.